Why is forward dynamics important for robot motion? Imagine trying to predict how a robot arm will move when you push its joints. That's where forward dynamics comes into play. It's like a crystal ball for robot motion, helping us see what will happen next. In robotics engineering and development, knowing how a robot reacts to forces and torques is essential. It's not just about making robots move, but making them move accurately and smoothly. When designing a robot or working on its mechanics, engineers need to understand how physical forces translate into motion. Forward dynamics helps connect the dots between the forces applied and the resulting movement of each part. This is different from inverse dynamics, which figures out what forces are needed to produce a certain motion. Forward dynamics solves the equations of motion for the robot, often modeled as a system of rigid bodies linked by joints. It uses algorithms based on Newton-Euler equations to do this efficiently. This process allows engineers to simulate how a robot will behave over time, which is vital before building the real thing. It helps in testing different control strategies and ensuring the robot responds correctly to commands. When robots interact with their environment, like gripping objects or walking, forward dynamics predicts how external forces will affect their motion. This is especially useful for tasks requiring precise manipulation or balance. It also guides designers in optimizing robot structures and actuator capabilities. For example, if a robot's arm is too heavy or its joints are too weak, forward dynamics can show how these factors impact movement. It involves solving complex equations that relate mass, joint positions, velocities, and external forces. The equations include terms for gravity, Coriolis effects, and external forces at the robot's end effector. Solving these gives us accelerations, which we can then integrate to get velocities and positions over time. Algorithms like the Newton-Euler method are commonly used because they handle complex kinematics quickly and accurately. This makes forward dynamics a key tool in real-time control and simulation software. Overall, forward dynamics links the physical design and control inputs to actual motion outcomes. It's a vital part of making robots that are reliable, precise, and capable of performing complex tasks. Without it, predicting and controlling robot motion would be much more guesswork than science.